for joining me in the morning. My name is Sona. As Laura mentioned, I'm a 3D printing analyst at IDTECHEX, and I'm really excited to discuss one of my favorite up-and-coming 3D printing fields, ceramic 3D printing, with you. So before we start, allow me to just quickly introduce my company, IDTECHEX. IDTECHEX is a British market intelligence firm based out of Cambridge, providing market research on a variety of emerging technologies. Our topics cover a pretty wide range, as you can see, from robotics to printed electronics to healthcare, and of course, 3D printing, which is my area of focus. We embed ourselves within our fields as analysts to try and achieve technical depth in our reports. And we have lots of primary interviews and continuing conversations to really bring understanding to our readers. And our reports include technology assessments, market outlooks, company profiles, and of course, market forecasts. So to introduce 3D printing at IDTECHEX, we have a variety of reports, including an overview report that covers the entire industry. We then split that into a hardware report, which I just released, and a materials report, whose update is coming quite soon. More recently, we had highlighted up-and-coming specialties, if you will, with 3D printing composites and ceramics, as well as an essential component of 3D printing, the hardware. If you have any interest in talking about 3D printing further, I am all ears at any time, so feel free to reach out at my email. And just a quick note to drop in, we are recruiting both in open topics, which can include 3D printing, but other topics as well. We're a very tech-focused company, so if that's your interest, feel free to check out our website for more information or email me for questions. Now to the topic of today, 3D printing ceramics. I'm sure when someone first thinks of 3D printing ceramics, they'll imagine a 3D printer that's extruding, let's say, clay to make cool pottery or cool sculptures. And while this is where ceramic 3D printing first began as a field, it has now evolved much further to focus on the printing of advanced ceramics. It is more common to see ceramics like silicon carbide, zirconia, and alumina being used for demanding sectors like chemical engineering, automotive, and aerospace. The parts pictured here include experimental catalyst supports, an optimized static mixer, and a mixing shaft. And today, I hope to demonstrate how the field has evolved beyond clay extrusion to more exciting possibilities. For the purposes of our discussion, ceramic 3D printing refers to 3D printing where ceramics are the primary material being printed, while that may refer to or involves intermediary like sacrificial materials, like say a polymer binder. Ceramics are still the final product in ceramic 3D printing. We also won't be talking about glass as much because while glass 3D printing technically exists, there's very few practical uses of it in the moment. So why should we use ceramic additive manufacturing or ceramic 3D printing? The big thing is that a lot of your traditional ceramic manufacturing techniques often have high initial or recurring costs. This includes ceramic injection molding or hot isostatic pressing, which is actually very similar to the issues faced by traditional polymer-based manufacturing, let's say injection molding. And so ceramic additive manufacturing can target these techniques at a lower volume of parts. And that is the best targeting for ceramic additive manufacturing, rather than those with a very high throughput, like let's say dry pressing or slip casting, because at those high volumes, other methods become just much more economical. To give you an idea of the history of ceramic 3D printing companies, I think the major point I want to get across is that ceramic 3D printing is young when you compare it to polymer and metal 3D printing. Polymer 3D printing and metal 3D printing, those began to get commercialized, patented out in like the 1980s, early 1990s, with industry titans like Stratasys and 3D Systems being founded 30 years ago. Those fields then sort of blew up just about 10 years ago as patents expired and more companies could enter the field. In the case for ceramic 3D printing, while the actual patents for the technologies go back a bit earlier into 2000, commercial ceramic 3D printing, that all started about 10, 11 years ago when the major players in ceramic 3D printing began to get founded. So you have quite a few different types of companies that are appearing on the field. So you have some dedicated ceramic 3D printing companies like, say, Lithos or IDTECHEX. You have companies that make printers that happen to be compatible with ceramics. Think mainly X1 and VoxelJet. Then you have companies who are using their own proprietary technology to make parts. And on this timeline, the only one that's really doing that is DDM. And as you can see, there's quite a few companies that have stepped on. And there's quite a few more companies that are coming into the field, which I will highlight in the next graphic. So after these past 10 years of development, where does the field stand in terms of the technologies and materials developed? So I really want to highlight that current standing with the next few slides. First, a technology overview of 3D printing ceramics. When I say technologies, I mean which 3D printing processes are compatible with ceramic 3D printing and have commercial players operating in those technologies to bring ceramic 3D printing to the market. This graphic gives you an overview of those players and which technology they belong to. First and foremost, vat photopolymerization involves the use of a UV curable resin that is then cured by some UV light source, either a laser or a general light mask, to build parts layer by layer. In the case of ceramic 3D printing, you're loading that with ceramic powder. So what happens is you load a resin with ceramic powder, you print said resin, then after printing, you debind the ceramic part and sinter it to make it form a fully dense ceramic part. Vat photopolymerization happens to be the market leader in ceramic 3D printing as a whole, as a plurality of companies belong to vat photopolymerization type technologies. First, you have SLA with companies like 3D Ceram, SK Fine, Photocentrics about to step into the field. And then you have DLP with Lithos, Admatech, Tethon 3D, all developing their own ceramic DLP exclusive printers. Next, over in the orange is extrusion. Very general here when I say material extrusion, because there's different types of extrusion technologies based on your feedstock. So I have listed here pellet extrusion and paste extrusion. The reason I don't have filament extrusion listed here is because at the time of making this, there were no filament extrusion printer makers that were on the market and commercial. Now there is one, is Geron Technologies, and I believe a few others looking to commercialize in the next few years. So you will probably see a new sort of part of the pie opening up quite soon. But based off of what we have in the current moment, pellet extrusion involves using ceramic injection molding pellets as their feedstock. But once you extrude it, it's very, very similar to your classic filament extrusion printers. Next, you have paste extrusion, which is more or less where the commercial field started. These are the first ceramic printers to really get any sort of presence on the market, with companies like Cerambot, Wasp, 3D Potter, all developing and making ceramic printers for artists and designers. However, with the exception of Rapidia, all of these are desktop printers, which is less of where the field is moving towards. Next up in the teal-ish color is binder jetting. This is where metal 3D printing players like X1 and VoxelJet have entered into. Like I mentioned before, their printers just happen to be compatible with ceramics. I wouldn't call them the majority of what X1 or VoxelJet does. Last but not least, we have material jetting, specifically nanoparticle jetting, as pioneered by XJet. Most other material jetting technologies, like Stratasys's PolyJet or 3D Systems Multijet, focus on using just photopolymers alone. NPJ, on the other hand, is focused on using ceramics and metals. So it's the only real player in this field at the moment. Although after attending Formnext this year, I think you'll see that category expand in the coming year. Next up, I want to talk a little bit more about your materials here. You can approach ceramic materials with a variety of sort of angles. First and foremost, you could approach the materials by your feedstock types, where you have paste, pellets, filaments, resins, powders, and suspensions. It's noted that the majority of these, so your resins, filaments, and pellets, use a plastic polymer binder. In the case of resins, your UV curable binders. In the case of pellets or filaments, a thermoplastic binder, to develop the ceramic powder into a printable feedstock. Whereas ceramic powders can be just used straight up in binder jetting or selective laser sintering. You also have suspensions made of ceramic nanoparticle used specifically by XJet, and pastes that are used by your desktop printers for, let's say, sculptures and design applications. Next up, you could also look at your materials based on the application they serve. Now, the 4 applications listed here are fairly general categories discussing ceramic materials as a whole. You have structural clay ceramics, which include, brick building materials, tiles, sewer pipes. You also have refractories, which are ceramics that can withstand a high temperature without any melting or decomposing. And those are commonly used in furnace lining, metal refining, power generation, etc. While those are interesting forms of ceramics, you're not really seeing those used to make 3D printed parts. You're going to see 3D printing in whitewares, which refers to pottery, porcelain, tableware, etc., which is what most desktop ceramic printers tend to be used for. Or more importantly, technical ceramics. Technical ceramics, sometimes called advanced ceramics, engineering ceramics, so on and so forth. These include a variety of different ceramics like alumina, zirconia, silicon carbide, silicon nitride, etc. Most important thing is that your industrial ceramic 3D printing market, most of what I am talking about today, is really focused on printing technical ceramics because they can be applied in high performance fields, highly demanding fields that require something like a ceramic to be effective. Last but not least, you have ceramic 3D printing materials on the market based on the actual composition of the ceramic. This is a table giving the 3D printing materials based on the type of ceramic. So oxide, non-oxide, and bioceramics. Most importantly, these are the actual commercial materials available for purchase. It's excluding sort of experimental materials or materials that are not sold by 3D printer manufacturers, but they claim to be compatible. From that perspective, you have oxide ceramics as a sort of dominant 3D printing material type in the ceramics market. For example, alumina, zirconia, silica. However, non-oxides are really starting to gain more traction because they are very helpful in very highly demanding applications, let's say automotive or energy. Bioceramics, as the name implies, is geared towards medical applications and dental applications. And then you have some other ones like cordierite. Now, as I've mentioned quite a bit before, the technologies and materials being developed today are really focused towards opening up more exciting applications for 3D printing ceramics. Question is, what are those applications? To give you an idea of the main target sectors for 3D printed ceramics at the moment, we have medical applications, meaning implants, especially facial implants. You have dental applications, like let's say crowns. You have chemical engineering applications, like static mixers. Arts and design, as previously mentioned before. Other emerging applications refers to a very wide variety of fields where 3D printing ceramics is being researched or investigated. So this includes space, like antennas and telecoms. This includes energy storage, with ceramic 3D printing being used to maybe make fuel cells and fuel cells 3D fuel cell sort of materials, and a pretty wide variety of other emerging fields like electronics as well. The one application I'm going to highlight for you today, since unfortunately I go on applications for an entire day, is investment casting. But I hope this sort of graphic sort of gives you an idea that there are a fairly wide variety of fields where you can use 3D printed ceramics and where it's currently being applied, and that it does have a lot of potential. Now, moving on to just discussing one specific one, investment casting. Well, what is investment casting, first off? Metal casting or investment casting is more of a traditional metal shaping process, where first you create a ceramic shell. That ceramic shell is then used to pour molten metal into. Once you cast that molten metal, you form the final metal part. As you can see here, it's a pretty complex process involving multiple steps. Now, while investment casting can produce very large parts and also create fairly intricate parts with smooth finishes and high dimensional accuracy, it's also capable of producing parts made out of nearly any metal on the market. The problem with investment casting is that it's ridiculously time-consuming compared to other metal shaping processes, and it's also much more labor-intensive than other metal shaping processes, which increases your production time. In addition, because it's multi-step, labor-intensive, and requires specialized material, you have quite high initial tooling costs, which makes this not so useful for one-off parts or lower volume productions. In addition, to make really complex internal structures like cores and holes, it's not the best for, and it's not great with design flexibility because of that long production time. Now, where does ceramic 3D printing come in? Ceramic 3D printing really simplifies this process by sort of eliminating these initial wax and patterning steps that are typically required to make the mold shell. So by eliminating several of these early steps, you very quickly get to the actual metal and casting part of investment casting. This reduces your production time and your costs substantially. So in this case, I think this is a really interesting application because ceramic 3D printing isn't straight up replacing the metal portion or the metal part here. It's instead making the process a lot easier. By making that process a lot easier, you allow for faster iterations of design, greater design flexibility, and integrating internal portions like chambers or holes that improve your functionality. And those functionalities are things that injection molding cannot produce. So it is a really great opportunity for 3D printing to simplify a traditional process that's otherwise just very complex for everyday usage. And there are companies that recognize that. So these two companies, Perfect 3D, which is a subsidiary of Renaissance, a aerospace integrated company, as well as DDM Systems, focus exclusively on using ceramic 3D printing to make investment casting cores and molds to produce parts like those pictured. You can use investment casting, especially in aerospace. Lots of engine parts, gearboxes, pipes and ducts, etc., can be made with investment casting. So it's an excellent opportunity for ceramic 3D printing to really show off its merits. Last but not least, I want to leave you with sort of an outlook of ceramic 3D printing as a whole, where it's going, and is the ceramic 3D printing market indeed taking off? This chart here is a chart showing the overall applications of ceramic 3D printing across many fields: medicine, chemical engineering, etc. The key things that this chart is showing is, first, where that application is in the commercialization process, and if it's been commercialized, how far it's penetrated into the market that it seeks to target. Now, as you can see, a whole lot of these applications are in the commercialization stage. They're not yet in the market out there for people to use. However, you'll notice these lines which indicate sort of how far we think that ceramic 3D printing application can penetrate into its main market. And you'll see quite a few dotted lines extending far into the commercial market. We think that ceramic 3D printing has really high potential. And as these technologies get closer and closer to commercialization, ceramic 3D printing will continue to grow and really start to make an effect on the end markets that it's seeking to target. And so, having said that, yes, IDTECHEX does really think that ceramic 3D printing is starting its rise. It's starting to take off. IDTECHEX forecasts that the market will reach around 400 million in market size by 2032, which represents a 7-fold increase in market size from today. You might wonder, like, well, that's not a crazy high market size, but it is relative to where it stands right now. And it is still considering that ceramic 3D printing is not something that will completely displace the rest of the 3D printing market or the rest of ceramic manufacturing. However, it's a very useful technology that has its place in complex, cost-effective components for high performance, high revenue generating sectors like aerospace and chemical engineering. If you have any questions or would like a copy of the slides or have other questions about IDTECHEX, please feel free to email me at s.dazania@IDTECHEX or contact me on LinkedIn. As well, you can click here and go on our website to check out the report that I authored on this. Thank you again for your time, and I'm happy to take questions.
Thank you so much, Sona. That was really interesting. It was a great summary of the whole industry at the moment. We will squeeze in one question. Apologies, we did start this session slightly late.
Not a problem.
So the question I was going to ask is, what are the main technical challenges for the industry at the moment, and where do we need more research?
Right. So I think the main technical challenges is that to an extent, some of the parts being produced don't quite match the properties of more traditionally produced ceramics. And this is in particular to the sort of layer by layer nature of 3D printing. And so whatever technical research is done to improve the mechanical properties or improve the material properties of 3D printing ceramics, then you'll see more applications, especially demanding applications, open up.
Great. So thank you very much again, and thank you everyone for attending. As I said, Sona will be available on the chat function or via LinkedIn, and this will also be posted up on YouTube afterwards. Thank you very much, Sona. Enjoy the rest of your day and enjoy the rest of the conference.
Thank you. Thanks for joining me.